We are recording.
Okay, we are now standing on the inside of an old mill building. There is a quarry just up in the woods a little ways from here. This is where they quarried the red sandstone that makes up the old Smithsonian building, quote, the castle, unquote, on the mall. The building here is built of that same red sandstone. It's technically called Arkose because it's very rich in feldspar. The grain size is too small though, and you can't really see the feldspar just looking at it. So a geologist would guess that it's feldspar by the red color and by little flakes of muscovite mica that sparkle in the rock. Not much of it, but just enough to see. Those don't define Arkose, but they're very characteristic of it. So any geologist would make a guess that this is Arkose. The rock itself was deposited in a fault basin that was formed when the old continent of Pangaea, giant continent composed of Europe, Africa, North and South America, also Antarctica, Australia, and India.
Well, it had it all.
It had it all. It was one gigantic continent. And it was composed during the Paleozoic when all the various continents collided with each other. The collision came to a head about 270 million years ago. The continent lasted for a little less than 100 million and then started to pull apart again. And the various fault basins along the east side of North America formed at that time. These fault block basins, called grabens, run all the way from the maritime provinces, where similar rocks are exposed in Nova Scotia and underline the Bay of Fundy between Nova Scotia and Maine. They're found in the Connecticut Valley, running down the Connecticut River from New Hampshire and Vermont down through Massachusetts and Connecticut. The Newark Basin in Newark, New Jersey. Gettysburg Basin. The Culpeper Basin in Virginia, extending across into Maryland here. This is the north end of the Culpeper Basin. Various basins in the Carolinas down to northern Florida, where you can't see the basins because they're buried under more recent rock, but they still are there. The biggest of these basins today is called the Atlantic Ocean because that one kept on moving. It's been moving for 180 million years. And it's been moving at the rate of a couple of inches a year. It still is today. You can see the crack running down through the middle of Iceland, and they can actually measure. You can survey the motion on each side of the crack, and you can climb down into it if you're so inclined. So if you're planning a trip to Europe, go as soon as possible. It's getting farther away all the time. On the other hand, since the continent is moving west, if you're planning a trip to Japan, you can put that off, because we're getting closer on that side. Not that it makes a great deal of difference, of course. These rocks up and down the coast do contain dinosaur fossils, a few dinosaur bones, not much, more dinosaur footprints. They were originally identified as giant bird tracks, although there aren't any birds quite that big. Still, they weren't too far off, as the birds today are classified as a sub-branch, very small sub-branch of the dinosaurs. Dinosaurs are more closely related to birds than they are to lizards. Okay, the building here, as I say, is built of that same red sandstone, and this is actually the best place to see it here, unless we spend more time hiking up into the woods to get the quarry, but that takes a little bit too much time and we're running short. So we'll stop right here and look at some rocks further down closer to the